This will be the 27th video in my series on three-phase power transformers. In this next series of videos, we're going to look at a various assortment of transformer protective relays, both old and new. We're not going to spend a lot of time on the older installations, although you will find a lot of the older type relays are still in existence because they are still functioning and still working fine, and they still protect the transformer. However, I'm going to show you some relatively new transformer relays that are called IEDs, or Intelligent Electrical Devices, that are basically computers that work extremely fast and provide a multiple of functions for the protection of transformers. We're also going to look at the oil flow protection, the Buchholz relay, which is used in most of the oil immersion transformers that exist today. This is just a very small portion of my course entitled Electrical Three-Phase Power Transformer Fundamentals. You can access this and my other courses on my Stan Store at this web address. An intelligent electronic device, an IED, is a term used in the electrical power industry to describe microprocessor-based controllers for power system equipment. IEDs receive data from sensors and power equipment and can issue control commands such as tripping circuit breakers if they sense voltage currents or frequency anomalies, or raise and lower voltage levels in order to maintain the desired level. Included in the realms of IEDs are the modern protective relaying devices. Some recent IEDs are designed to support the IEC 61850 standard for substation automation, which provides interoperability and advanced communications capabilities. In utilities and industrial electrical power transmission and distribution systems, a digital protective relay is a computer-based system with software-based protection algorithms for the detection of electrical faults. Such relays are also termed as microprocessor type protective relays. They are functional replacements for the electromechanical protective type relays and may include many protection functions in one unit, as well as providing metering, communications, and self-testing functions. The digital numeric relay was invented by Edmund O. Schweitzer in the early 1980s. SEL, Areva, and ABB groups were early forerunners, making some of the early market advances in the arena. But the arena has become crowded today with many manufacturers. In transmission line and generator protection, by the mid-1990s, the digital relay had nearly replaced the solid state and electrical mechanical relays in new construction. In distribution applications, the replacement by the digital relay proceeded a bit more slowly. While a great majority of the feeder relays in new applications today are digital, the solid-state relay still sees some use where simplicity of application allows for simpler relays, which allows one to avoid the complexity of digital relays. The progress and enhancement of these relay changes happens continually, and as such, the following examples have already been improved and additions made. However, the basics are still there, and even though newer versions are available, these examples will give a good idea of what is out there and what has happened in the way of IEDs for transformer protection today. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also, from time to time, be reviewing electrical products that, in my opinion, are worthy of paying attention to. This address will give you access to the supplier of the aforementioned type products. It is also a connection to obtain a free copy of my 24-page three-phase transformer workbook, which will serve
as a quick reference and reminder of technical calculations that you may need. This address, of course, is case sensitive. I'll spell it out and make sure that you have it right. Everything up to the first number is lowercase. That is lowercase https://bit.ly/3, then uppercase U, uppercase G, a lowercase j, uppercase B, uppercase I, and lowercase g. One of those amazing and versatile products is the 𝐃𝐈𝐒𝐂𝐋𝐀 Delta Pro Ultra, which can be modified to suit any homeowner's needs, operating virtually silent, and when paired with the 𝐃𝐈𝐒𝐂 Smart Home Panel 2 is extremely versatile. The 𝐃𝐈𝐒𝐂 Home Panel 2 ties any and all of your standby power equipment together and will control them efficiently. It will even control your connection to the utility grid to make sure you're only using the least expensive power, switching to your standby power during those expensive time of use rates. In order to view the full range of 𝐃𝐈𝐒𝐂's products and obtain a free copy of my 3-phase transformer workbook, check into this web address and simply provide your email address, which will guide you to browse the full extent of their products. There is no cost or commitment for viewing, and by providing your email address, it will allow me to keep you posted on future videos, courses, and 𝐃𝐈𝐒𝐂 products. Before I end this video, I want to repeat the connection to obtain a free copy of my 24-page 3-phase transformer workbook, which will serve as a quick reference when working on my courses and quizzes. It is also a handy reference and reminder of technical calculations required in your daily job requirements. Finally, here is the link to all of my electrical courses, which are located in my stand store.